So what do rainbow colored chemistry, super strong steel, giant batteries, and sea squirts of all things have in common? And that's the element vanadium, right? So vanadium is atomic number 23. It's got the chemical symbol V. It's a group 5 metal. So that means it's got 5 electrons in its outer shell. So here's the electron configuration right here. And it's 50.9415 grams per mole is the atomic mass, right? Now, vanadium was initially discovered in 1801 by Andre Manuel del Rios. And so he was looking at some mineral brown lead. He called it brown lead, and he thought he had a new element. He asked a colleague in France, a French chemist, what he thought about that, and he was like, well, it's probably just chromium. So it wasn't until 1830 when Niels Gabriel Sefstrom in Scandinavia actually was working with vanadium chloride compounds and was able to prove vanadium existed. He called the new element vanadium after the Scandinavian goddess for beauty and fertility, Vanadis. And that was because of all the bright colors, the brilliant colors that were possible with vanadium compounds, right? So you've got purple, green, blue, and yellow. And that depended on the oxidation state, because vanadium compounds can give you oxidation states from 1 to 5. And that also makes it really useful for redox flow batteries. And so vanadium ions in different oxidation states can store large amounts of electricity. And what's cool about this is useful for grid level energy storage, where you can go decades with a minimal energy loss. Now, vanadium steel is incredibly strong. And so 85% of the vanadium produced is used to strengthen steel. It doesn't take much. Only about 1% vanadium added to alloys will greatly increase the alloy's strength, toughness, and resistance to wear. So vanadium steel is useful for a lot of engineering applications, cars, tools, all sorts of things. Now, interestingly, in 1911, a German chemist, Martin Henze, he was looking at blood cells in sea squirts, and he found these blood cells had concentrated vanadium up to about 1 million times more than seawater. Why is this? Who knows? He doesn't know. We don't know. This is still a great mystery.